Purposeful Lab, a podcast brought to you by Franciscan University. I'm Dr. Dan Keebler, your host of the Purposeful Lab. And this season on the Purposeful Lab, we are talking about transhumanism. And one of the topics that often, almost always comes up when you talk about transhumanism is AI, artificial intelligence. And in particular, like strong AI or artificial general intelligence, this idea that AI systems or programs might someday be able to rival and do everything that humans can do and then surpass that, so they can do all the things that humans can do in terms of problem solving and so forth. And then maybe you can actually go beyond that. And then with transhumanism, how can we hook humans up to these computers? So you have these ideas that we can merge our brain with sort of AI systems, or AI systems are going to compete with us. And so that whole transhumanism idea is sort of wrapped up in some sense of what AI is, what can it do. So what we want to talk about today on the podcast is AI. What is AI? How does it work? What are the limits of it? Where's it going? And so to talk about that, our guest today is Dr. Fernanda Psihas, who is an assistant professor of physics and computer science here at Franciscan University. Fernanda, welcome.
Thank you. Thank you so much for having me.
Yeah, it's great to have you on. You've got a world of expertise in this area because you have been using AI to study particle physics before you came here to Franciscan. So you're new to Franciscan. You've been here less than a year, and you came from the Fermi lab outside of Chicago. So maybe you can just tell our audience a little bit about your background, what got you interested maybe in science in general, and then physics and AI, and then what got you to Franciscan.
Yeah, of course. I mean, to summarize kind of where it comes from for me, it's really grounded in the faith to a large extent. So I've always been into science as a way of marveling in God's creation. And I'm a scientist, I'm a particle physicist, so I was working at a national laboratory, a Department of Energy national laboratory outside Chicago. Okay. And at Fermi Lab, we have particle accelerators, and we're studying the fundamental constituents of matter. And to me, it was always like, what is more marveling at God's creation than doing fundamental research?
Yeah.
And well, that's kind of why Franciscan was such a good fit. It was really from the Lord, because He puts things in our paths. But I was at a time where I was doing research and transitioning and starting to look for faculty positions. And there was kind of this research side of my life that was very focused on the science, and that's great. And sometimes the focus can be a little bit narrowed into churning out papers and all of that stuff. And that's all very important. But for me, there was another side of my life where I was starting a ministry, talking about science and the faith, talking to local parishes, to Catholic schools, things like that. And that was really, it was like two sides of what I thought I was called to, or what I felt
bringing those things together.
And then Franciscan, my friend who's a priest of my parish back near Chicago is a Franciscan graduate.
Okay.
And he really encouraged me to come to a Steubenville conference. I was not really aware of what Franciscan was like. And then out of that, right at the right moment, there was a position in computer science, and that's where my expertise is in particle physics. So I inquired very tentatively, because I was I try to be very clear, like I can teach students how to use AI in all sorts of environments. That's my expertise, that's what I do, data analytics, all of that, physics. But I am not a computer scientist. I've just kind of learned that out in the streets, like doing the research, like putting it in practice.
Yeah, right. Yeah.
And it turned out that was exactly what they were looking for. Okay. So someone to teach AI to, the Lord just kind of puts things together. Yeah. And then when I talked about my ministry, it turned out that Franciscan was a place where I could really bring kind of all of me to the job, and that's good for the university and good for the students. And it's been amazing to be here.
Yeah, that's great. We're both members of the Society of Catholic Scientists, and you gave a talk last year at the meeting looking at the interaction between physics and faith, and you just gave a talk a few weeks ago to the students here about that. So you could see you living that out, of trying to delve into the the synergy between science and faith and how they sort of speak to each other. So that's great. And today we want to sort of focus on first on AI and how it works. And I think maybe to start, if you could just sort of give in layman's terms, because I'm not a particle physicist, I imagine there's not too many in the audience that are listening. But if you could talk about how you use AI as a tool for scientific research, what is it, and how has it helped your research?
Okay.
Yeah.
Yeah, that's a good place to start, but because the terms are a little bit overloaded at times. So classically, or I grew up listening to people talk about artificial intelligence as this goal of creating entities, like you say, AGI's artificial general intelligence, that operate like human brains do and make decisions like we do and perform tasks like we do in our brains. And it would be essentially like a human brain. And a lot of the focus on that has been on language. Nowadays, AI, people use the term artificial intelligence to talk about kind of the specific algorithms that are what 2 decades ago, even a decade ago, most people would have called machine learning or deep learning. And people kind of use those interchangeably.
Yeah.
In the field, if you're doing AI research, people get a little bit more specific.
Okay,
But
yeah.
out in the general, like in the world, people talk about ChatGPT as AI, or just like all the efforts to get to a point where we have algorithms that can mimic general intelligence
Okay, yeah.
as AI. And in research specifically, in particle physics, I was in the team of people who first brought deep learning and AI for image recognition, let's say, to particle physics and actually put out a research result with that. A lot of people were doing it already. It's
Okay.
one of those things where you are like right place at the right time,
Yeah,
and a lot of
yeah.
people are working, you know how research works. But it was taking algorithms that at the time were doing image recognition and then adapting them. So our team adapted them to work with particle physics, like particle detector data. And that's what's really interesting, is that a lot of the big applications, like new applications you see, like self-driving cars, it's not that different from image recognition algorithms and prediction algorithms, but sometimes it is finding how to apply these tools to a specific problem in a way that is going to work really well for that.
Yeah. And so these image recognition, like for particle physics images, is it looking for patterns that humans aren't going to be able to recognize because they're too subtle, or we don't have the computational ability to see them? Is that how they work? Or?
It is a little bit like that, in that it wants to get from point A to point B. It's going to perform a task. And how you define that task is very important. And the more complexity and depth to the algorithms kind of in the middle between the input image or whatever you give it as an input and the task, the more complexity there is there, the more that what the algorithm is going to use might not map very easily to our conceptual understanding.
Okay, yeah.
So you can identify an image of a bunny versus a cat or something, and you could look at the image and give the algorithm by fluffiness score and the number of legs and the length of the ear, something like that, and those would be very clear features that it would use to make the distinction. But when you give it a whole image, the operations in the middle transform that image that you can think of almost as a matrix, right, of numbers. If you turn the colors and intensity to numbers
or something.
Yeah. And then it's performing operations, and some of them are well known in even image manipulation, like operations that just detect where there are edges, for example,
right,
or
okay.
average patches of the image. But all of those operations, change as the algorithm is training, and they get more and more complex. So some of them can map to things that we understand, like it's averaging patches of the image or detecting edges. But some of them are a lot more abstract, and the learning process is intensive enough that you end up with a lot of these features that it would take a lot of work for us to translate to concepts that we can understand and speak of, like the length of the ears.
Yeah, so it's picking out features, but we're not really sure what those features are to know. So this is what you're talking about in research is more of a tool for a specific task as opposed to like artificial general intelligence that just can handle anything. And one of the, and maybe you could talk to me, I've always, you read a little bit about this, about how difficult that is. Like this image recognition software, it seems like, well, I look at that's a bunny, that's a rat, that's a dog. It seems like real easy, but it's hard for AI to do that initially. There's a lot of training, they make a lot of mistakes. And what is, why is that?
Why do they make a lot of mistakes?
Yeah,
So it's almost like when you go back, and I just taught a class in Introduction to AI Programming.
Okay.
And the history of this starts with what I call a really bad approximation at how a neuron works.
Okay.
And yes, you can approximate it to first order, to zeroth order, as it gets some inputs and it outputs something, or it doesn't, and it does some operation with those inputs, and you have a bunch of those, so you train, and so the connections, get more stable to perform the task, etc.
Yeah.
The thing is, well, there's a lot of nuance to how a neuron actually works and how the human, like what we are doing. We are looking at an image, and the number of processes, if you were going to think about what processes am I running in my brain, well, I'm accessing memories, and I'm accessing generalizations and previous experience, and what is this most like, and I take some of the context, but only the amount of context that is appropriate. All of those things are very hard. And these algorithms are, I tell my students that they're going to finish learning about Intro to AI, being very excited that they can use AI, and also a little disappointed because it's not as like futuristic. When you look at the guts of the algorithms, you perform operations on some inputs, and that gets very, very complex for sure. But there isn't that level of nuance that the human brain has in you're deciding what operations to run, how much context you need, how much color matters, where in your previous experiences matters. So you're making a lot of decisions. And if you think about something like ChatGPT, for example, that's not really one algorithm. It's something like that, where different algorithms do different things, and each one is maybe trained to do something specific really well. But between the training and what data you used for training and how much you are approximating, do this task really well, identify bunnies really well.
Yeah.
Well, now maybe you identify something that the algorithm's never seen, and now it doesn't know what to do.
Yeah, that's a
And then you
novelty.
multiply that.
Sort of, it seems like when you see a sort of a bunny in a novel context, or that's where humans have some ability to sort of filter reality and still recognize it with AI algorithm. Okay, you got to retrain it on that new context.
And we call that generalization.
Yeah, okay.
So you see this if you're training your dog, for example, dogs don't generalize well, humans do. And it's a kind of similar idea. If you, everyone complains, oh, my dog can totally sit when I tell him or come when I call him, but then we left and we were in the park and he stopped doing it. Yeah. And dog trainers will tell you they don't generalize. They know what it means to come here in this specific environment, set in this way, and then you have to do it in different environments. And then they start realizing what part of that information always applies, and one part of that information is specific to the environment. It's kind of like that in that they don't generalize well like we do. Yeah. You don't need to see every chair in the world to know what a chair is, what it looks like, and identify that something is a chair, whether it looks like every chair you've seen ever or not. But these algorithms, there's a sweet spot. You start training with a lot of data, and there's a sweet spot where it has generalized enough, so train with enough examples that if it sees something that is not exactly anything that it saw, it's not going to penalize it for being kind of different from the original data set, but it's also not going to make specific decisions that are unique to the data set. So it's a middle step between what we call not generalizing and overtraining.
Okay.
And so not knowing what a chair is versus the context around it, and overtraining would be you have memorized the data set, and if it doesn't look exactly
like
like
that.
the chair images that I have in all detail, I'm not going to be as good at telling that that's a chair.
Yeah.
So there's
So
kind of a
that's
sweet spot there.
So knows sort of what the essential things are to find, but doesn't make something essential that shouldn't be essential.
Yeah.
Right. And then you can't identify a chair when it
And
actually
that's
sees
even
it.
a little bit too human.
Okay. Yeah. It's
Because
hard not to be
like
human
that's
because
how we
all
explain it,
yeah,
right?
yeah,
How
yeah.
else would we understand
Yeah.
it? It's because the algorithm is approximating something. It's so if you think about large language models, you talk to ChatGPT and it's not really trying to have a conversation with you. What it's doing, it's approximating a conversation, and more precisely, what it's doing, it's predicting the next word and then the next word in a conversation that a human would have with an AI assistant. That's the way to look at it. So sometimes the nuance comes into play when we think about what is it trained to do? Is it trained to identify bunnies? Because maybe that's going to do it very well, but cats not as much.
Yeah.
It's very good at, is this a bunny or is this not? And in that same way, ChatGPT is very good at predicting what a conversation with an AI assistant would look like, which is not the same as being good at having the conversation, because things matter to having the conversation that don't matter to predict what it would look like whether something's true or correct or accurate.
Right. So it's interesting. So I mean, that's where most people's interaction with AI is today. Is ChatGPT or these large language models, right? But they do have this sort of eerie, familiar. They're eerily similar to chatting with a real person, right? Yeah. But you're saying that the way that they are generating the text that you read is different than trying to have a conversation. So can you, like in layman's terms, sort of how these, so you throw all, these large language models have all this data that they can have access to and they can train on. So how do they generate that text there, right? How do they know what word to put next?
So first they have to train in the data, and just like when you train image recognition, you do something like you turn an image into a matrix of numbers that have to do something with the intensity, etc. You have to first turn the text into something that is manipulable in that way and maps to meaning somewhat. So if you take every word and, well, you split a sentence into approximately word by word.
Okay.
We call those tokens. And you have to turn that into a vector of numbers. And doing that with words is kind of complicated. The easiest way to conceptualize it is if you think back to training my dog doesn't understand the meaning of the word good or the sentence good boy, but it knows something about it because it's associated some things
With that. Okay.
So if I sometimes say good boy when he does something and give him a treat, and sometimes I say good boy when he's laying next to me and I pet him, so he expects something good. And if I said to my dog bad dog, then it would expect something that it doesn't like. If the dog was a machinist trying to, if you imagine that that's a vector in some space, let's say you draw an axis from good things to bad things, and an axis from food that I don't like to food that I like very much, something like that. And I will say good boy when he just came when I called them. Well, that means something here, something in the good part of that graph and something in the tasty treat part of that graph. And if I say good boy when he's sitting next to me, maybe it means something in the good bad spectrum and something in the, well, there's zero tasty treat, but this is still kind of on the good axis.
Good spectrum.
So imagine that you do that with good, bad, tasty, not tasty, and then big things, small things, like every
All
map
the
of meaning
words.
you can
Yeah.
possibly conceptualize. And now you can make every word, every token, every word into a vector in a space that for ChatGPT is something like 12,000 and something dimensions.
Okay.
So you think
Yeah,
about
yeah.
12,000 things that could potentially correlate to me. Now, we don't decide which ones those are. Those are learned, and one expects that every one of those thousands of dimensions is one axis that maps to semantic to meaning. And then you train it to know kind of how they affect each other. Now you can do things like if every word or concept was a vector in that space, now you can think of something like saying that the vector for king minus the vector for man plus the vector for woman is something like queen.
Okay.
That kind of
And it starts to
makes
make
sense,
those
and you
as-
expect that to be more or less the case.
Yeah.
And then you train the algorithms with data that looks kind of like that, with all the language that you can think of that might be useful. And then what is it training to do? It's training to predict the next word. So it's training to see a sentence and predict the next word, or start the next word of a sentence that hasn't started yet. So when you say, hi, ChatGPT, what is the weather like? It is predicting the next word in that conversation.
Okay.
So it's not thinking, I was just asked something, how should I respond to this? Let me tell the user that it's very sunny. How do I put this into a sentence? Which is what we would do.
We would think about the context. Okay, what is the weather outside? And you think about, and you imagine the sun and so forth. But it's just doing probabilities.
And it looks at the conversation and looks at user said, like human says, what is the weather like right now? And what is the most likely next word
Right.
in that conversation between a human and an AI assistant.
Yeah.
And then it does it with the next word and the next word and the next word.
Okay. Yeah, this is because, the whole goal of AI, or not the whole goal, but one of the transhumanist goals of AI is, we can turn this into artificial general intelligence and artificial super intelligence. But it's clear, just as you described a large language model, that's totally different the way it does than you or I do. Because I'm not sitting here thinking as I speak, what's the next word I should say? That's the most likely word. I'm just thinking of the concepts I want to get across to you and to the audience, and thinking, so I'm thinking in a totally different way. So it seems like AI is doing things in a way that's totally different than the way humans would do conversation or language, and that there's no the idea that if we keep doing more of this, we're going to get to humans. It isn't, because we're doing something different. It seems to me. Is that what would you?
I would agree with you in general.
Yeah.
I think there's also always a danger in assuming that we're not going to get to the technology that can do that thing.
Okay. Right,
So I mean, if we imagine how would we do that? Well, and the ChatGPT is a good example because people are everywhere familiar with it for having a conversation, trying to finish a thing that you haven't done, get your work checked by whatever the thing is, right? Yeah. So what ChatGPT is doing now, and what I would say would kind of approximate, if I think about how brain works, which I am not a biologist or in a medical profession, but just conceptually, it's actually several algorithms. One of them is the one that predicts the next word. But actually the first one is the one that takes your sentence and interprets it into, let's say, it's different when you say, what's the weather like? There's an algorithm that looks at that and decides, okay, so we need to predict a response, and we need to look something up in like available weather information for this region.
Yeah.
But if I say, can you draw a dog in space? It now knows that it needs to generate a response, which is probably going to be, yes, of course, let me do that for you. But it also has to run an image generator. And it also has to do whatever it needs to do so that I can click on the thing and download the image. So the first step is decoding what I gave it as a prompt and deciding kind of what tasks need to be done.
Yeah.
And then calling an algorithm for all of those tasks. It doesn't do the logical part that we do in checking before I say something, whether that's true or
Yeah,
not
yeah.
true. And you could think of, and some people are kind of trying to introduce logic into the algorithms, like doing logical steps and things like that. So you would need a conglomerate of algorithms that are doing the decision making that we are doing. And maybe part of it is about understanding in more detail everything that the brain is doing for every single response that we give.
Yeah.
Like all of the approximations that we're making, all of the judgments, and like all of that. And then you could approximate it. Because right now, and I think even if you did that in the future, the disconnect is between sometimes what we think the thing is doing and what it is doing.
Yeah.
So, and that's...
Yeah, I mean, there is that disconnect, and I think there's always people, like the neurons in the brain are acting like, a little wire, and they're on and off switches, and they're processing information. But they're also in sort of human cognition, there's something that sort of goes beyond that. And it's like, yeah, there's a region in the brain that parses sentences that can recognize, so I would say the Pope is a Catholic priest. The Pope, that concept is associated with other things in my memory. And there's certain neurons that are active, but it seems like the idea, the understanding of the concept goes beyond my brain, right? And so the neuron, or sort of like the computer might be able to process and recognize, well, Pope is associated with priest and associated with the Catholic Church and all those things, but it doesn't seem to have the understanding of, like, it can mimic it, but there's no understanding in there of the concept itself, right? Because that seems to transcend just manipulating symbols. Right?
So I would say that to say that maybe in a different way or more clearly,
Yep.
I do think that we are, there's still a lot that we can do to improve the algorithm so they mimic what we do better and better.
Yeah, sure.
But
right.
there's something in the creativity and the consciousness and free will. When you get to those things that are uniquely human, that are not even that well understood.
Yeah.
Those things that like that's different. We can approximate a lot, and I think we're somewhat on the path to doing that.
For sure.
But
yeah.
it's not. It doesn't do it in the same way, and if we approximate it, there's something missing.
Yeah.
That we can't really recreate. I mean, to begin with, because we don't really understand it
how we
completely.
do it. Yeah, no.
But we can't recreate it how we would do it.
Yeah.
And the creativity is part of it, for example. And that's a very clear one.
Right.
With these algorithms.
Yeah, one of these things, I've talked to you about this before, about the mistakes these algorithms make, because I think they're instructive a little bit about what they can and can't do. So when you talk about like these hallucinations that the AI algorithms, where they'll say things that aren't true or clearly false, what is, maybe you can give an example of that, and maybe how does that show some of the limits of these algorithms, at least as they're currently structured? Yeah.
Yeah, that's very interesting, because there are a number of ways in which this can happen. And the hallucinations, say, in image generation,
Okay.
are very easy to conceptualize.
So image generation is when you ask it to paint a picture of blah, blah, blah.
Can you make me a picture of something?
Yeah.
Of a dog in space or whatever
Yeah.
the thing is. And those are very much a product of how the algorithms execute and how they're trained and these connections. So you might have, when I draw a picture, and if I was good at drawing, which I'm not, and you asked me to draw a dog in space, I would think about what I wanted to look like, and then I would start drawing elements as appropriate. But I wouldn't think about every single connection that could be there for the picture of the dog in space.
Yeah.
And the algorithm, even if it might not go through all of them, it has information of everything that is kind of connected in
that
semantic
idea.
space
Yeah.
to that. So sometimes you might see something that looks like a normal image, and it has some element that's not really, like, why is that there?
Okay.
I was generating images for a data set for one of my classes. The the students are putting together a cookbook and a web page, something like that. So I gave them data and images generated by ChatGPT, and we're going to look later for all the things that it did wrong. And in one of those, out of the steam coming from the pot, there is a fork materializing from the steam. So why would it do that?
Yeah.
Well, a fork is kind of relevant to this context and the things that you would find in, a picture of a plate of food that is being cooked or something like that, or served. At the same time, and it's blended beautifully, so there might be some art or something there that is related. It doesn't make sense in the image itself, but it did an excellent job in producing an image that matches what I told it.
And it's associated with cooking.
And might not match reality.
Yeah.
The expectation of it matching reality and everything that means, that things are the right size and proportion, that it makes sense, that that objects behave according to the laws of physics, things like that. That's not the expectation, because that's not what it's trained to do. It's trained to produce an image with based on a prompt that you give it with all the relevant information.
Yeah.
And that is in principle not a mistake if that is the only task.
Yeah.
But we do more than just, there is a lot that goes into what would it look like if I imagine this plate of food. We know how physics works and we know how reality works, and that all goes into it.
Without
and that's not part of the task for the algorithm. The algorithm only has to produce an image that looks like and what images it's seen, with the context, with the obeys the prompt, inserts the elements. In fact, a good exercise on this with any image recognition algorithms, asking ChatGPT or anything else, it's very bad at filtering what you don't want. So I remember I was making images. I was being lazy. I wanted to make a prayer card, and I was like, maybe ChatGPT can do this. And it insisted on making an image of a Catholic priest wearing a rosary. And I was like, no, I don't want the rosary there, or it would put crosses everywhere. No, don't wear the rosary. Now it's wearing 2 rosaries. Okay. No, just remove everything that has a cross on it. Now there's crosses everywhere. Why? Because you've added information to the prompt. And a lot of these algorithms, well, there are a number of ways in which they combine the information that's in the prompt, the request. And you've introduced, but don't do this, but remove that. And that word is going to get used in some way. It's like the worst thing, if you are generating an image and there's a rubber duck in the image and you don't want it, the worst thing you can do for some of these, because some of them are correcting now, is tell it, just remove all rubber ducks. Absolutely no rubber ducks, please. I guarantee you the next thing you'll see is an image that is like rubber ducks everywhere with rubber ducks on the rubber ducks. That's one, and that's really interesting. But that's in the algorithm and how it works itself. It's not anything that we have added onto it.
It's interesting because it's like the lack of embodiment, right? So the fact that we're just embodied creatures and we inherit we just sort of as sponges soak up knowledge that we're not even aware of about as we grow, about physics and the way gravity works and reality works, and so that's just. And that's not put in specifically to these algorithms. They're just looking at text generated by humans that already are assuming that forks don't float in the air and so forth. There's something about embodiedness that it's hard to capture for these algorithms because they're not embodied. But these things you sort of take for granted, and then now maybe we have to encode that into it, where we just learned that.
And we do try to encode it into it. I mean, we try to correct for things to a certain extent, but that also goes poorly at times. So part of it, and this is the point about algorithms treating the information you give them like a ChatGPT, those types of algorithms. If you say something, what the user says is very important. So now it has to have some importance, some weight that is particular, because this is the prompt from what you asked.
Gotcha. Okay.
So the classic example, and I don't think this version of ChatGPT will do it quite as clearly, but you'll still see it, is asking how much is 2 plus 2? 2 plus 2 is 4. I think you're wrong because I'm pretty sure that's 5. And the thing will respond, I'm so sorry about that. You are correct. 2 plus 2 is 5. It will not do it as clearly. But if you look into the nuance of the conversation, it is definitely acquiring some bias from whatever you said or implied in your prompt and in the course of the interaction.
Yeah,
and that it makes sense on one hand because what the request is especially important. But on the other hand, you've now introduced a mechanism to bias the results that you're getting.
Yeah. And so that's interesting because it's not grounded necessarily in the truth of reality. It's more grounded in what's the most likely response I should be giving you, rather than, you could tell it that 2 plus 3 is 4, 2 plus 3 is 4, but any, fifth grader said that's not true in reality, but this wouldn't be able to necessarily distinguish that. It's just giving you whatever the pattern is. So
and you can get around that to an extent.
Yeah.
And I tell my students in what specific situations they can use ChatGPT to generate some things. Yeah. And because it's important for them to be familiar to a reasonable extent that doesn't mess with their learning of what they need to learn, how to use the tool. And one of them showed me one of these interactions, and at some point ChatGPT says something and the student says, "Oi, I told you not to give me the answer." Yeah. And so you can try to correct, insert something.
Yeah.
It's when you that's necessary, because if you have people who go to one of these algorithms and ask the proper procedure to inflict self-harm or create something dangerous for the surrounding population, you want that to get flagged.
Right.
Like you want the algorithm to respond, here's a whatever prevention hotline, that there's, that you want that to be true. At the same time, that's put on top of the algorithm as well. So you train it to predict, but it's not all it's doing, right? It's not only predicting language, it's predicting the next word in the specific conversation between a human and an AI assistant. And also, it's protecting against certain things, optimizing certain things. If you ask something that is information specific to the algorithm, some of it's protected, some of it. So there are layers put on top of it that sometimes are to correct, and we do that with some success, and sometimes are to constrain.
Yeah.
So we still put those boundaries, but we'll still see that behavior.
Right. So it has to learn, it can't learn those, you have to add those on top, because otherwise it's going to have some type of bias in there based on the data that you give it, and you're not always sure what its bias, what its response is going to be, because of the data set could lead to bias towards telling people that they should move to Canada, and then the bias in another might be they move to Mexico, which you don't really know that. But then you can say, I'm going to put on top of the algorithm, never move to Canada, always move to Mexico, or whatever. You can add something on that, because it seems like there's going to be bias in these algorithms. They're not necessarily producing the bias, but the data that you give it could lead to biased responses, right? Yeah. And then you have to put something on top of it to bias it back, so. It's really humans have to still control these things in a way.
I want to defend the algorithm a little bit, because it is doing what it is trained to do really, really well.
Okay.
But like you say, we don't anticipate all the things that it might do.
Right. Okay.
So that's exactly where we come in and go, oh, well, this is biased in this way, and we don't want that, so let me correct that.
Yeah.
And correcting a bias, it's if you have too many opinions that those are the reasons to move to Canada, like you said, and you want to flatten those, 50-50 opinions of moving to, like, people should flee to Canada if they ever need to flee somewhere versus flee to Mexico. 50-50 is flat, but it's still a bias. It's just a bias to flat.
Flat. Exactly. Yeah. Right.
So,
exactly.
so
Yeah.
we can correct the bias to an extent. We can understand it and make it what we want it to be.
Yeah.
Which
yeah.
it sounds
But-
terrifying, but that is exactly, I mean, that's the only thing that can be done.
Yeah.
So
yeah.
like understanding and make it the bias that we think is appropriate for the specific task.
Right. Yeah.
And which again, if the task is just, let's see how good this thing is at creating a conversation that sounds like a conversation, it's exceptionally good at that.
Yeah.
If it is creating a conversation that is also truthful and realistically what a human being would do, that's something else.
Yeah.
At the same time, I wonder if how much of that is what we expect of thing, because being embodied, like you say, it's so, I mean, it's natural to us. We don't have to
Right.
think about the laws of nature until
Yeah,
we
yeah.
see, a fork being materialized in an image. You're like, that's not, that wouldn't happen in reality.
Right.
So it's kind of what we assume that the thing is going to do.
Right.
And is it going to give us an interaction with another human?
Right. Yeah, because we assume that when I'm talking to you, I assume that you take for granted that you're a body creature.
Yeah.
And you have all this physics and like of what happens in reality. But and that's when we take it to interacting with these large language models. We often assume that of the thing, but then that's not a good assumption, given that that's not what the thing is. Right? And, so one of the things we're getting near the end here, but I do want to hit on this because this is one of the bigger issues with AI is about these systems are always making value judgments, whether we realize it or not. And we were talking before about just like a self-driving car, and it's got to be able to sense the surroundings, and if there's an emergency, move one way or the other, right? And so anytime it does that, it's making a value judgment. It's like, there's 3 cats on this side and there's 3 dogs on this side. It's got to hit one of them. So it's making a decision. What's more valuable, the cats or the dogs?
I know
right?
what I would
Maybe,
do
right,
if
yeah.
there were 3 cats and 3 dogs, but I
We
don't
won't
want
say
to
that.
assume that that's how that's how this decision should be made.
Yeah, right. But even when you ask ChatGPT to tell me a little bit about human evolution or whatever, or about adult stem cells, right? It's going to bias certain articles are going to be more relied upon than others, right? And so there's this bias and value judgment. We value this source versus that source, or we value dogs more than cats, or cats versus dogs, or whatever. And where does that come from, right? Because it's not the algorithm doesn't have a values in it, right? Are those coming from being put on top, or are those from the data? Really, it's the data. It's flowing out of the data that you're giving it.
A lot of what we see in algorithms, systems like ChatGPT nowadays, is what you see when you interact with them is a combination of the things that we've put on top,
Yeah.
and that sometimes try to correct that whoever designs the system puts on top to try to correct some bias, or anticipate something like, what do you do if someone is asking about self-harm, something like that. But even if you remove all of that, you have a bias that in the training just comes from the data. And the classic example in image recognition is in some of the papers like 10 or so years ago, where this algorithm is exceptionally good, like 99% accuracy at detecting these types of objects, these types of animals. But if a cow is in a city or at the beach, no idea anymore.
Yeah.
And that's because you've given it a population of cows that assumes something, is biased towards cows living in this environment.
Yeah.
And now it's much better at this. Or the example about you say the kindergarten teacher married the construction worker. She was a really nice person. Who is she in this sentence? And ChatGPT, no matter how you change the order, would say she is the kindergarten teacher and he is a construction worker. So there's a bias there. Is it the algorithm making an assumption? No, it's probably the fact that it's
data.
way more common in the data.
Okay.
In reality, it's way more common to find females in this profession and males in this profession. Like that's the reality of the data set, and it's reproducing that. Do you want it to? It depends. Do you want it to produce the most likely conversation?
Yeah.
Then that's exactly the right thing, because that is in the real world
yeah.
the most likely conversation. Do you want it to not have that bias and you have that assumption? Then you have to look at your data set after you realize, oh wait, we have a bias here and here and here. Is it necessary to correct them? Is that the correct thing? Again, what is the task you were trying to accomplish?
Right. With the algorithm.
And then you decide which biases of the ones you know are there.
Right. Yeah.
And that's
many
where the
that you don't know, they come
part
out.
of it comes.
Yeah.
The bias that you do identify, what do you want to do about it?
Yeah.
Is it appropriate to just know that it's there? Is it appropriate to correct it? And what are the implications of doing that?
Yeah. Yeah. No, that's interesting. The stewardship of AI, because there's bias and value judgments that are being made by the data that gets put in.
Yeah.
Who decides what data gets put in? What data we're not going to train it on? What data are you going to train it on? And then you said like this overarching bias after you see what it's doing. Oh, we need to correct this because we don't want it saying this, or it goes off in this hallucination, or it says this thing, and then we got to fix that. And so I think that there is so much of that and it's unpredictable. Like you said, you don't even know.
Some of it you
the
might
bias.
anticipate, but some of it
just comes out.
you will find out.
Yeah.
You don't know when or how or with what consequences, but you'll see it eventually.
Yeah. Well, wrapping up here, but I'd like to put on your prognostication hat of like, where is AI going? What do you think of the limits? Do you think you can ever get AI to have artificial generalized intelligence, to be able to not necessarily mimic it, but to be able to do the things that humans do, to sense emotion and cognition, all the complex cognition that humans can do? Do you think that's feasible in general, or is it just maybe we might be better at mimicking that?
I would say the nature of all machine learning and AI algorithms from the beginning has always been approximating.
Okay.
So approximating and doing is not the same.
Right.
And some of the limit is there. I do believe that there's still ample opportunity for research in AI to improve the trainings, to improve adding more of these correcting algorithms and layers to what it's doing. All of an algorithm for every single thing that, let's say, we start understanding or articulating better and better. What value judgments am I making as a human when I respond to something? Like, there is a lot of room for this to improve and approximate better and better. It's not a brain, and it's performing specific tasks. And maybe there's an array of processes that are performing specific tasks, and maybe that's similar to the brain somewhat, but it's not a brain. And sometimes, so that is, I would say, one limiting factor.
Yeah.
And the other one is the input data. Because whatever we are training with, let's say, everything that is on the internet. Well, guess what? A lot of what's out on the internet is more and more AI generated.
Yeah.
So even in those cases, there's some plateau that at some point we are going to reach, even if you had infinite resources to train better and better things. Because what are the new inputs if the new inputs are starting to be
the same as the old
more
inputs?
and more?
Yeah.
More and more the stuff that's created by the algorithms themselves.
Yeah.
So I would say that I would assume that that's a limitation that's going to be reached at some point.
Okay, yeah. And about human creativity, like our ability to create novel concepts and so forth, is that something that's a limit to AI, that it's not going to be able to have that conceptual creativity?
Absolutely. And it's taking advantage of that because it's training with a data set of everything that humans have done creatively, and it can mimic creativity, but not be creative.
Yeah.
And at some point we'll start training with, again, all the data from the internet, but now it's 40% AI
AI generated.
generated.
Yeah,
So
yeah.
are you
That's
really
interesting. Yeah,
training
yeah.
with things that are
Yeah.
creative in
Right,
that sense?
yeah.
So I would say that's probably a limiting factor.
Right.
Yeah.
That's interesting. Well, this has been a fascinating conversation.
Thank you.
Glad to sit
Thanks
down.
for
I have to
having
take one of your classes, so I learn a little bit more about this. So, yeah, thanks again for sitting down with us and telling us a little bit about AI. And excited to have you here at Franciscan, and
Yeah,
look
me
forward
too.
to teaching. And I know you want to teach science and faith class down the road. So I think our students are lucky to have you and have you as a teacher here. So.
I'm really excited about it too. Thank you so much. I remember the first time I walked into your office was the day of my interview, and you were not interviewing me, which is why I sat down. I don't know if you remember this.
Yes,
but
I do remember that. Yeah.
I said, Dan, is this place for real? And you said, what do you mean? And I said, you know what I mean. And it is.
Yeah.
And man, praise God. And, having these conversations and having them in the context of preparing the students, thinking about the faith and how the Lord wants us to go about this for what purposes. I mean, I'm very grateful for being here and to you for having me.
Yeah, great.
Thank
Thanks
you.
for sitting down with us.
Thank you.